Scope: the project will utilize a pre-trained LLM as the foundation and fine-tune it with custom medical data to enhance the quality of diagnosis and responses. Techniques like RAG and web scraping will be employed to get relevant medical information from trusted sources, further developing the model's knowledge database. By combining the capabilities of LLMs with retrieval techniques, this project aims to create an accessible and reliable medical chat doctor that can assist patients in navigating their health concerns more effectively. Current stage of the project. As of right now, a retrieval-based question answering system has been put up. It finds questions that are similar from a preloaded dataset and uses the responses to inform a different question answering model. Retrieval augmented generation is a technique that we haven't used yet, though, and it involves gathering relevant information from a broader corpus or knowledge base. What's done so far? We have developed a pipeline that accepts a user's input question. We have utilized a pre-trained sentence transformer model, which is the All-Mini LM L6 V2, to convert the input question into a vector representation. Then we have loaded a JSON dataset, healthcare magic 100k.json, containing medical questions and their corresponding answers. For each question in the dataset, encoded it using the same sentence transformer model and stored the vector representation, question, and answer in a dictionary D. Then we have saved this dictionary D as a JSON file using a custom NumPy array encoder to handle the serialization of NumPy arrays. For a given input question, we computed the cosine similarity between its vector representation and the vector representations of the questions in the dataset. Then we have selected the most similar questions based on similarity threshold of 0.6 and concatenated their answers to form a context. Then we have passed this context to a BERT-based question answering pipeline to generate the final answer to the input question. Steps to be implemented further. Fine-tuning the models. Consider fine-tuning the sentence transformer model and the BERT-based question answering model on the healthcare magic dataset. This step can help the models better comprehend the medical domain and potentially improve the quality of the retrieved answers. Or else, we can use the RAG technique. Instead of relying solely on the preloaded dataset, you could set up a retrieval component, for example the DPR or the BM25, and incorporate a larger corpus or knowledge base of medical information. This approach would enable the system to retrieve more comprehensive and up-to-date information for answering questions that may not be covered by the preloaded dataset. And then evaluating and testing. Evaluate the performance of your system on a separate test set or real-world scenarios to identify areas for improvement and potential limitations. User interface and deployment. Depending on the project requirements, we have to develop a user-friendly interface like a web applications or a chatbot for users to interact with the medical question answering system. Important components of the project: LLM, RAG, web scraping, and the front end. Workflow. A user submits a query which is encoded into an embedding vector using the query embedding model. The query embedding is used to fetch relevant context, like documents or information, from the vector database by finding the most similar embeddings stored there. The user's query and the retrieved context are combined and fed into the LLM. The LLM processes this combined input and generates a final response, which is presented to the user. Working of this component. Integrating the RAG model with LLM. Utilize the transformers library to seamlessly integrate the RAG model with the LLM. This integration will enable the system to leverage the RAG model's retrieval capabilities and LLM generation capabilities for providing comprehensive responses. Setting up the backend server. Establish a backend server using a framework like Flask, Django, or Fast API. This server will act as an intermediate, facilitating the communication between the front-end interface and your Python code that incorporates the integrated RAG model and LLM. Then create the front-end interface. Develop a user-friendly front-end interface using a modern web framework like React, Angular, or Vue.js for a web application, or we can use Electron for a desktop application. Implement implement question submission. When a user submits a question through the input field, initiate an API call from the front end to the backend server you have set up. Backend processing. In the backend server, upon receiving the API request, we need to pass the user's question to the Python code that incorporates the integrated RAG model and LLM. Utilize the RAG model to retrieve relevant context or information related to the user's question. Combine the retrieved context with the user's question and feed it to the LLM. The LLM will then generate a comprehensive answer based on the provided context and questions. Displaying answer in front end. In the front end interface, upon receiving the response from the backend, dynamically update the designated section or the area with the generated answer provided by the system. Dataset used. The dataset we have used here is of JSON format. The dataset consists of around 1 lakh question answer pairs. The link to the dataset is given over here. Data processing. The process begins by converting the user's question into a numerical vector representation using a special model called an embedding model. This vector is then used to find similar vectors stored in a database. The database contains vector representations of different pieces of information or context. Once the similar vectors are identified from the database, they are combined with the original user question. This combined input is then fed into a powerful language model. The language model uses this combined input to generate a final response or answer. By considering both the user's question and the retrieved relevant context, the language model can provide a more complete and accurate answer. Technology framework. For the front end, we are using HTML, CSS, or JavaScript, and then React.js. Backend, or the server side, we would be using Node.js with Express, along with Python with Flask or Django. For the machine learning and data processing, PyTorch can be used as a backend for fine-tuning and training models like BERT and GPT-2. Hugging Face can primarily be used for building and fine-tuning transformer-based machine learning models for NLP tasks. Sentence Transformer. Sentence Transformer is a Python library which is built on top of Hugging Face's Transformers library. It is specifically designed for generating vector representations. FAISS. The FAISS is used for efficient similarity search. It is from Facebook. It stands for Facebook AI Similarity Search, which can help us in RAG. Thank you.